In the next step, after the formation of 1,3-bisphosphoglyceric acid, another molecule of ATP will be generated and one phosphate will be removed from our substrate. 1,3-bisphosphoglyceric acid is the substrate on which the enzyme will act, and this enzyme will convert this 1,3-bisphosphoglycerate into 3-phosphoglycerate, and the enzyme involved in this kinase reaction is phosphoglycerokinase. Phosphoglycerokinase will catalyze this reaction and will convert 1,3-bisphosphoglyceric acid to 3-phosphoglyceric acid, and one phosphate will be removed from the substrate. And here you can see that there is a formation of ATP from the substrate, means we have removed the phosphate from the substrate and generated the ATP. So this production of ATP at the substrate level, production of ATP at the substrate level is called substrate level phosphorylation. So this is the step in glycolysis where substrate level phosphorylation happens when 1,3-bisphosphoglyceric acid is converted into 3-phosphoglycerate or 3-phosphoglyceric acid, and this reaction is kinase reaction, and there is an generation of ATP molecule. And as I discussed earlier that there would be two molecules of glyceraldehyde 3-phosphate, hence two molecules of 1,3-bisphosphoglyceric acid and two molecules of 3-phosphoglyceric acid will be produced. So plus there would be the generation of two ATPs at this step. So overall 2 ATPs were invested in the initial stages in the priming phase and or preparatory phase, and two molecules of NADH plus H have been generated after the splitting of fructose 1,6-bisphosphoglycerate into glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. So here we have two molecules of reduced coenzyme NADH plus H, and there is generation of two ATP molecules up till now.